Integrated positioning can be a huge benefit for any engineer because all the standard control code and motion control code is developed in a single engineering environment, which saves them valuable engineering time as well as commissioning time. Let me show you how easy it can be. As you can see, here's the S7-1500 controller, ET200 SP distributed I/O, and a comfort panel, all of which is on Profinet. And here is the S120 we want to do the positioning for. Well, if you come over to a project, you can see all the hardware configuration is complete. So now we want to do the positioning. First step is we come over here to our technology object, double click on add new object. We get a little dialog box that pulls up, and as you can see here we have a couple of choices. We have speed access, positioning, and external encoders. For this example we're going to use the positioning, give focus to it, click OK. So now it's going to pull up the entire dialog for doing the positioning for this S120. Let me actually give complete focus to it. It gives us a real nice graphical representation of the user program, the technology object that's going to actually be located in the actual CPU, the drive and the motor. We are going to do a linear position, and we're going to use engineering units of millimeters. That's fine. Let's go down to the hardware interface, give focus to the drive. So now you can see we have a drive, the controller, and the actual motor. If I click on this little button, it's going to allow us to navigate down through the hardware configuration section and find this actual drive in our hardware configuration section. All right, so let's go down. There it is. Give focus to it, click OK. So now it's going to tie this technology object directly to that drive. Let's go to the encoder now, and you can see we already have as a defined connection to the drive. That's the default. We can accept that. That's no problem. Let's go to the data exchange. And you can see here I need to change a couple of things. The reference speed needs to be 6,000. Click enter, and the maximum speed, the same thing, 6,000. If I come down here to the actual encoder types, you can see our default is incremental, but of course we have the availability of absolutes as well as incremental encoders, but we're going to leave the default. Let's go down to the extended parameters and the mechanicals. Here it gives us the option to actually choose where the actual encoder is going to be located. Is it in the shaft or is it directly located on the motor? We're going to leave the defaults with this as well. Go down to the dynamic limits. As you can see here, I have a maximum velocity, maximum acceleration, and DXL, ramp ups, ramp down times. I'm going to leave all defaults, no problem. Let's go down to homing. The active homing, you can see it gives us a nice graphical representation of what it will do to find the home position. If I change it, let's say to another one, you can see it's a different type of graphical representation. Let's go back to the default, that's no problem. And last but not least, here's the actual control loop gain. So if you want to do some fine tuning, all I need to do is change this to 50 for this particular application. That way I can fine tune the actual control loop located in our controller. All right, let's now go over to our program blocks. And as you can see, I have two new blocks here, two MC blocks for the interpolator and the servo. Give focus to the main OB, double click on it. So as you can see in our main OB, we have no program. What I want to do is come over to the task card and go down to the technology section for motion control. Let me give focus to this, and now you can see our PLC open blocks that are available to us for programming. The first one I would like to use is the MC power. Let me drag and drop this into the project. Accept the default data block. Now let's actually tie this to the TO we've created for positioning. Let me drag and drop that over to the axis input. Now I want to enable this. I want to use the input 0.0, click enter. Now I'd like to do a home MC block. Let me drag and drop this into the project. Accept the default data. Now I want to tie this to the TO as well. Drag and drop it over to the axis input. Again, I want to execute this one as well. So I want to use input 0.1. Now I'd like to do some absolute moves. So let's drag and drop the first one in. Accept the default data block. Let's tie it to our TO. And our execute is going to be an input 0.2. Our position is going to be, let's say, 400. And our velocity is going to be 1,000. Of course, I could actually use tags instead of absolute values. But in this instance, I'm actually going to use absolute values. Let's do another absolute move. Accept the default data block. Let's tie it to the TO. Let's execute this with input 0.3. And our position is going to be 200. And I'm going to use the standard velocity coming from the technology object. You'll see we have some -1s and next to acceleration, decel, so on and so forth. And this is derived directly from the TO. So now I want to give focus to our CPU. Click the download arrow button. And now he's compiling everything that we've done up to this point for the actual TO and the actual programming itself. Click on load and click finished. Now I want to give focus again to the main CPU. Click go online. Once it has, in the actual TO itself, we'll see underneath we have something called commissioning. Give focus that, double click on it. And we see we have some kind of error here, so I have right underneath it something called diagnostics. Let's give focus to that. Has some type of drive or data exchange problem, so let's go back to the commissioning. Let's click on confirm, clear the error. So at this point I should be able to come over here. I can power up the drive, so that means our program's working just as it's supposed to. If I click on the home position, you see it finding the home position. And let's do our first absolute move. And let's do our second reverse absolute move. I was able to accomplish all this in just a matter of minutes. Now that's engineering efficiency.